Alright, so we're going to be on 10.2 today, which is on page 7. Okay? We're going to be looking at theoretical and experimental probability. Now, we've done experimental probability already. Yesterday, when you conducted those experiments with rolling the dice and with flipping the penny, those were experimental probabilities. Those were experiments. Okay? When we talk about an experiment, we're talking about conducting the scientific method here. Like in science, this is the scientific method. This is how you solve a problem. You start with a problem, you ask a question about the problem, you do some research to figure out an answer. You go, hey, I think this is the answer. You conduct the experiment, you collect your data, you analyze the results and go, okay, I was right, or no, I was wrong. Okay, and then you try the process again if you were wrong. Experimental probability comes from after we experiment and we collect our data. So experimental probability is the probability that is based on repeated trials. So that is our experimental probability. Okay? I like to think of this as the one that we actually do it. Like we've actually conducted it, we've actually done the results, done the experiment, done the thing. Okay? Huh? It's experimental probability.
Wait, that's an R.
That's an RIMENTAL. It's up here too. Experiment. So yesterday we talked about relative frequency. Relative frequency and probability are the same thing. So yesterday we talked about creating a fraction where it was part to whole. Okay? Where the whole was the total amount of trials that we did. So yesterday we flipped the penny. How many times did we flip the penny?
20 times.
20 times. That would be my whole. However many times it lands on heads would be the part. Okay? And that would calculate, this would give us our probability or our relative frequency. Okay? So here we have where they did the same experiment as us. And it says the table shows the results of spinning a penny 25 times. What is the experimental probability of spinning heads? Okay, so what's the event that we're looking at? We're flipping our penny, but that's the experiment is flipping the penny. The event, we're looking at spinning heads. That's the event that we're looking at, is spinning heads. Okay? So we're going to set it up as a fraction. How many times did we spin heads? 6. How many total spins did I do in my experiment? 25. So experimental probability can be written as a fraction, a decimal, or a percent. So we can leave it as 6 over 25. Or we can convert it to a decimal. So in my calculator, I'm going to convert 6 over 25 to a decimal.
0.24.
How do you convert 6 over 25 to decimal? A couple ways. I understand the 0.24. Click on the 2 arrows, you can convert it. Maybe the 2 arrows. Okay, that will work. Also, what else could you do?
The percent.
Oh yeah, how do I get 6/25 to 0.24? I just want to know how you do that.
How are we changing it to a
What's the
decimal?
process?
So somebody said put it in as a fraction, you can hit the double arrows.
Good. And there's one more other way. No simple way.
What does the fraction also represent?
0.
Division. So could I just do 6 divided by 24? Yeah, if you put in your calculator 6 divided by 24, it's going to give you 0.24. Alright?
So
And then convert to a percent would be 24%. All of these are examples of how to write probability. Okay? These are the probabilities. Sometimes it'll be specific, like when you do your IXLs tomorrow, it's going to ask for the probability to be written as a fraction. So you'd put it in a fraction form. If it doesn't ask for a fraction, then I probably would change it to a percent. That's just me. Okay? But they're usually going to be specific in how they want it, or the multiple choice will have the format that it's supposed to be in. Okay? Alright, so let's turn the page. Alright, it says the table shows the results of rolling a number cube 50 times. Kind of like what we did yesterday. Find the experimental probability of the event. So our event here is rolling a 3. Okay? That's the event. So we want the event, okay, over the total. So what was the total? How many times did we roll the dice? 50 times. Of those rolls, how many of them were a 3? 8. I come over here, here's 3. The frequency is 8. That is my probability. Or I could simplify that. Okay, and I could change it to 4 over 25. Or I could change it to a percent, which would be 16%. All 3 of those are the probability, the experimental probability. I have a 16% chance of rolling a 3. What's the likelihood of that? Unlikely. Good. Okay. The next event is rolling an odd number. So we want the event over the total when we're talking about probability. Well, we rolled it a total of 50 times. Odd numbers. What are my odd numbers? 1, 3, and 5. How many times did I roll a 1? 10 times. How many times did I roll a 3? How many times did I roll a 5? Alright, so that gives me 29 over 50 as my probability, or I can convert it to a percent. Gives me 58%. What is the likelihood of that happening? Likely. The only way to be equally likely is what? It has to be exactly 50%. And this is over 50%, so it is likely to happen. Okay? Are we good so far? Okay? Keep rocking. Alright, this time we've got a spinner. We're spinning a spinner. Okay? First thing we need to know is how many times did we spin it? How can we figure that out?
Just add all
Add up all the times that were spun. So add all these up. 8, 6, 9, 11, 9, 7. Add those up. Don't shout out loud. Give everybody a chance to add them up. Write it down under number of spins. Write it down. Don't say it. All right, Mara, what'd you get? 56.
Why are we adding this up again?
Because if I'm looking for the experimental probability, I need the total and the event, right? So number 3, it says we want to know what the probability of spinning less than 3. All right? There's 2 different numbers, right? 2 and 1. Okay? Well, how many times did I spin a 1? 8. How many times did I spin a 2? 6 times. Out of how many total spins? 50.
14 over 50.
So my probability is 14 over 50. Convert, do not shout it out, but convert it to a percent. Alright, Parker, what'd you get? 28%. So my probability is, the likelihood is unlikely. The probability is 28%. Okay? Not spinning a 1.
Oh, 2. Certain.
Alright?
Oh, never mind.
We're finding the probability of not spinning 1. So we're looking at,
5.
3, 4, 5, 6.
2 through
So you
6.
gotta find 2, 3, 4, 5,
alright.
6.
So couldn't I just,
There's 2 ways to do this.
Alright.
Actually, what's the 2 ways?
Bobby said add, and then Parker, you did what? He just subtracted, because you need all this but that. So get rid of that from the total. Good thinking, Parker.
Both ways are fine. There's nothing wrong with either way.
That one's just a little
Equals
faster.
42.
Okay. So all of this added up gives me 42 out of a total of 50, which gives me a percent
84%.
of 84%. And the likelihood would be likely to happen. Alright, I want you to find the probability of 5 and 6. So spinning a 1 or a 3, find the probability of that, and then find the probability of spinning a 7. Don't shout them out loud, just put them on your paper. Do it, Reese.
Oh, I did.
Okay,
Six.
good.
Alright, so if I'm spinning a 1 or a 3, how many times do I spin a 1?
17.
How many times do I spin a 1? 8. How many times do I spin a 3? 9 out of 50. So that gives me 17 out of 50.
34.
34%. Either one of those would be correct. Alright, spinning a 7. It's impossible because we even have 7 as an option. 0%. Its likelihood would be impossible. Not possible at all. Okay? Alright, you're checking for defects. Okay, let's say you work for a factory that creates laser pointers and your job is to check for your quality control. And you're checking for defects. You check 20 laser pointers at random. Of those 20, 3 of the laser pointers are defective. What is the experimental probability that a laser is defective? How are we going to go about that?
We do
20 over, or 3 over.
we do 3 over 20.
Yeah.
We
The
put in
part over
percent.
the whole. What part were defective?
3 is
3.
a part and 20 is
And
a
how many did I check? 20.
So you get 3 over
50% would be
Oh,
50.
15.
So the probability is that 15% of those lasers are
It's gonna
going
be
to be
Unlikely.
defective. So it's unlikely for you to get a defective laser. Is it possible?
Yes.
Yeah, but is it likely?
No.
No. Okay. Good. Alright, that's experimental probability. You've actually done it, you've actually verified it and checked things out. The next thing we look at is theoretical probability. I like to think of theoretical as thinking about it. We're not actually going to do the experiment, we're just going to think about it.
guess your best thinking with, your thoughts.
My thinking look, while I was taking my test this Saturday, this was my thinking look. I was curled up in the chair like this, okay? And I was like this the whole time during the test. Pretty much. With my noise canceling headphones on top of me and my glasses.
What was
And then half the time I was like this, and those people were probably looking at me like, she's gone cuckoo for Cocoa Puffs. But that was my thinking face. Alright, so we're thinking about it. Okay, this goes back to our scientific method. Okay, so after you've done some research and put some thought into it, you think or you hypothesize that this is going to happen. Okay? It's the same setup. The number of favorable outcomes that it could happen versus the number of possible total outcomes. We've still got a part to whole situation here. So we got some letter blocks. What do those letters spell? Explore. Okay, we're going to explore theoretical probability together. They want to know, what is the theoretical probability of choosing a vowel? So let's say I put these blocks in a tub, in a bucket. What is the probability that I'm going to draw out a vowel? So what is the event in this situation? What are we looking for? We're looking for what? Vowels. That's our event. We're looking for vowels. Vowels are A, E, I, O, and U. How many vowels are in this bucket right now? 3. Out of how many total letters? How many total letters are over here?
7.
Out of a total of 7 letters. Alright? That's our probability. Our probability is we have a 3/7 of a chance of pulling a vowel. Now if I turn that to a decimal, I get a really long decimal. Let's round it to the nearest hundredths place, so 2 decimal places. We should get approximately 0.4.
for 14?
43. If we round correctly, because it was 0.428 da 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 da. The 2 looks at the 8, and the 8 tells the 2. 5 or more, go up. So I convert that to a percent, and that turns to 40. I have a 43% chance of picking a vowel.
It's unlikely.
Okay, it's unlikely to happen, but it could. What would be the theoretical probability of choosing an X from the group? Well, how many X's are in the group? 1 out of how many?
7.
So what's the theoretical probability? I have 1 out of a 7 chance. 1/7 of a chance. If we round it to the nearest whole percent, it would be about 14% chance of picking an X. It's unlikely to happen. Okay? That's not very different than what we've been doing, is it? No, it's pretty much the same things we've been doing. We're just repeating it. Alright, look at this spinner. We want to find what's the theoretical probability of spinning red. We can't actually spin that spinner, can we? No. Okay? What's the chances of me landing on red?
2.
2 out of what?
2 out of 6.
I have 2 out of 6 chance of landing on a
Red.
red. If I simplified that, it would be 1/3. Let's just leave it at fractions right now. We don't have to turn it to a percent. What's the probability of me spinning a 1?
1 out of 3.
1 out of 6. There's one out of 6 total spots.
1,
Alright?
2.
Spinning an odd number.
3 out of 6.
What are my odd numbers here?
1, 3, 5. 1 to 5.
1, 3, and 5. So we have 3 out of 6 chance
That's
which is half, which is equally likely to happen. Spinning a multiple of 2.
It's 3 out of 6.
What are our multiples
2,
of
4,
2?
6.
Skip counting by 2. 2, 4, and 6. Which gives me, how many are there?
3.
1, 2, 3. That would also equal 1/2.
6.
Alright, spinning less than 7.
6.
6
6 out of 6.
6 out of 6, which is equal to what?
1.
1 whole. So you have 100% chance of spinning a number less than 7, don't you? Alright, what about spinning a 9?
0. It's impossible.
There's not even a 9 on here. 0% chance. Good. Alright, each letter of the alphabet is printed on an index card. How many letters are in the alphabet? I've only been doing it since pre-K.
Hey, you're either good on that or you're not. Either good or you're not.
Alright, there's 26 letters in the alphabet. Maybe that's something you've learned today. There's 26 letters in the alphabet.
You get a question on Jeopardy like that, there you go.
Okay?
You'll
Hopefully on milestones, if you had this question, you would write out your alphabet and not forget a letter, and you would count how many letters you have.
Yeah, I don't want to see y'all, if y'all ever end up on Jeopardy, I don't want to see y'all go.
I'm gonna be like, I taught you that! Okay? What is the probability of choosing any letter but Z
25.
out of,
It's 26. 25 out
it
of
can't just be 25, it's gotta be
25 out of
25
out of 26.
25 out of 26 chance. You have a 96% chance, which is very likely that you're not gonna pick Z. Okay? Alright, we good so far? Alright, keep trucking. A blank, a simulation is an experiment that is designed to be reproduced or to reproduce the condition of a situation or process. It's usually used when we can't do it in real life. So like if we need a really, really big number, it would be a waste of time to roll your dice 5,000 times, wouldn't it?
Yes, ma'am.
Well, thankfully in the day that y'all live in, we have computers and AI and all those things that create a simulation that will convert it for you like that, okay? The computers know, I don't know how to do it, but computers know how to generate things, okay? So that we call that a simulation. So here we have a simulation that's been done for us, where they use technology to simulate rolling a number cube 300 times. How does the experimental probability of rolling an odd number compare with the theoretical probability? So we're comparing the two. We're looking at experimental versus theoretical.
First off, what's experimental again?
Where you actually do the experiment.
Okay, alright,
Right.
and what's theoretical? Somebody else besides Dalton?
It's where you think about it.
Think about it, okay? If you go, okay, if this were to happen, this would happen, or this is not, this is the odds, okay, yeah, think about
Okay, so experimental is what?
Think,
Where you
Doing it. Theoretical is
Thinking
thinking about
it.
it.
That's the big lesson.
Okay. So let's start with theoretical. Let's think about it first, because in our scientific method, that's what we would do first. We would think about it first. We're going to make a guess first. Then we're actually going to do it and see if we got close to the answer. Okay? So here's my dice. So thinking about a dice. We're trying to figure out, we're trying to roll an odd number. That's our event here, is an odd number. If you think about a dice, how odd numbers are on a dice?
3,
There's 3 odd numbers on a dice out of how many total possible
Six.
numbers?
6.
6. So if I convert that to a percent, because when we compare, let's convert it to a percent.
50% equals equal.
Equal likely, okay? That's theoretical, okay? So we've thought about it. This is what should happen. Theoretically speaking, I don't know if anybody's ever heard somebody say that. Theoretically speaking, there should be 50%. Now we're actually going to test it and do it. So the computer did the experiment for us, okay? And this is the results that we got. How many times did the spinner roll the dice?
300 times.
300 times.
There's 300 rolls right here.
On the bottom of it,
All right, so it rolled 300 times. Which ones are we concerned about?
300.
The odd numbers. So I'm concerned about 1, 3, 3, and 5. So I'm concerned, I need to figure out 48 plus 50 plus 49. I need to add those up without shouting them out loud. Without shouting it out. We gotta work on shouting things out. And we should get 147 without shouting it out loud. Convert it to a percent. Alright, Bailey, what'd you get? 49%. What do we notice about these percentages?
Oh, well, no,
Like in no, we're not talking about likelihood, you're right.
They're like close to 50.
They're really, really close to each other, right? How far off is our
One-
experimental from our
1%.
1%? Okay,
Which-
so if this was, listen, if this was our theoretical, if this was our guess, could we say that we guessed correctly? Could we say that?
If you round
Yes,
it.
yes,
Yeah,
yes, yes.
because most, the odds are, since we're talking about odds, you're never going to get exactly what you guess because there's outside factors contributing to it. So you never get the exact same number, but if you're really, really close, I would say I got this correct. Okay? So they asked us to compare, and I would say they are very close with a 1% difference. Okay? They being the experimental and theoretical probabilities are very close with a 1% difference. Alright, so using the same simulation, how does the experimental probability of rolling a number greater than 1 compare to the theoretical probability? So once again, we're comparing the two different things. We've got theoretical over here, VM over there, experimental over here. We're using the same situation from the example above. We're using the number cube. How many total possible answers are on a number cube? 6. how many of them are going to be, because our event says greater than 1. So how many of them are going to be greater than 1? 5. So without shouting it out loud, write down, convert that to the percentage. 5, 6, convert it to a percent.
Everything we said, like, big pieces of
So.
You should get 83%.
Point
We're going to round it. I know it turns out to be a really long number, but we're just going to round it to 83%. Okay? Now we're going to look at the actual experiment itself. How many times did we roll it? What was the total amount of trials that we did?
300.
We did 300 trials. Of those 300 trials, how many of them were greater than 1?
five.
How-
All of them.
140?
These 5.
Guys, okay, there's 5 numbers, but how many of times did you roll that number? 53, 50, 52, 49, and 48. So you gotta,
Do this, make it two and this. We can add up all the blues, or we can just subtract 48 from what?
alright, so you should have gotten, Dalton, 252.
Because you said you divided 48 by 52. Or, oh,
You took it out that, because you wanted everything else but the 1.
Oh, it's by,
So, don't shut it out.
okay, it says it what?
Convert it to a percent, you should have got 84%.
And it's, like, one down, it's less than one.
It's less than 1%. So could we say that these were very close?
Yes.
Yes. Okay. All right. Here we've got a new situation. We've had a simulation done. How many times did the simulation spin the spinner? 200. So 200 is our what? Total amount. Okay? That's the whole part. I want you, because our instructions say to compare the theoretical and experimental probability. I want you to find the theoretical probability of spinning a 4, and then I want you to find the experimental probability of rolling a 4. I want you to find those two things. Use your example if you need to. Look up above your notes and see how we did that. There were theoretical thinking about it. Experimental, we actually did it. Okay? Theoretically speaking, what are the total number of options that I have?
5.
5. I have 5 total options on my spinner. How many of those options are 4? One option. There's one option that's a 4. As a percent, that would be 20%. Experimentally speaking, means we actually did it. How many times did we actually do the experiment? We did a total of 200 times. In that doing, how many times did we roll a 4? Which gives me 18.5%, which is still pretty close. You could round it to 19%. Okay, so those are still pretty close. Okay. What if I wanted to look at the last one? Spinning a number greater than 4. Spinning a number greater than 4. Theoretically speaking, how many options do I have in all? How many total options do I have on my spinner? 5 options on my spinner. How many of those options are greater than 4? 1. Converted gives me 20%. Experimentally talking, how many times did I actually spin the spinner? 200 times. How many of those times were greater than 4? 40 times. I've got to quit with the shouting out part. We're going to start giving break pictures. That's going to probably be Coach Jones' job. Signing break pictures for shout outs.
Raise hands, make them call.
What can we say about those two? They're the exact same, right? Okay. All right, here's our last page for today. We can take our experimental data and make predictions about a larger amount. Okay, and that's what we're going to do here. That's what you did yesterday with your experiment. If a bag contains 50 marbles, okay, you're going to conduct an experiment where you take a marble out and then you put it back. But before you put it back, you record what you got. You do this 30 times. Predict the number of red marbles in the bag. What is our event here? What's the event? What are we looking for? Red marbles. We're looking for red. All right, we're looking at the experimental probability right now. We got to know the probability first. How many red did we draw? Bobby. 9. How many total times did we do it? Kenyon. 30 times.
I got it. Alright, so we had 9 out of 30 there. Okay, so we need to go ahead and figure out our what? Percentage. So let's figure it out. What is it going to be? 30? 30, okay. So we have 30% here. Got off to the side. Okay. Alright, so to make a prediction, okay, multiply the probability of drawing red by the total number of marbles in the bag. Okay, so we need 2 things. What? Well, we need to figure out what? Drawing of reds and the what?
Total number.
Yeah, and the total number of marbles. Those 2 things. Alright, so let's go take a look. Over here in our chart, okay, a little graph. Okay, we locate red first. That'll tell me everything. What does red say?
Total, draw.
Red, we got none of them. Okay, now, okay, to get the total, it's real simple. Add them up. 3 plus 12 plus 9 plus 6. Now, raise your hand and tell me you get an answer. Raise your hand when you get an answer. Don't answer. Raise your hand when you get an answer. All right, need everybody in class 3, 2, 1.
30.
Three.
3.
Wait, what?
30.
Total number. What's the total number?
30.
Oh, 30.
30, right. So since I underlined in black, you add them all up. Okay, you get 30. Okay, now, it says to make a prediction, multiply the probability of drawing red by the total number of marbles in the bag. Okay, so, how do we do that?
You said it?
So, our question is, like I said on the bottom, it says to make a prediction. We're predicting here. That's all we're doing is predicting. It says multiply the probability of drawing red. Okay, there's 9 red. So 9 out of how many is red?
Oh, 30.
Red, not red.
Oh, no.
9, so 9 out of 30.
What?
Drawing red, 9 out of 30. Okay, by the total of what?
30%.
A total number of marbles, which is what?
30. 270.
So 9 out of 30 and what?
9 out of 30 is 30%.
Oh, excuse me. Take a look. Hey, take a look at the very top. My bad, I missed this. What's this right here?
Oh, yeah.
There's what. Sorry, I knew I missed something right here. Right there is what? 50 marbles is our total. So if I had 50 marbles, we don't know the total number it's going to be. But what have I used in the past to help me figure these out?
30.
Cross multiply. She just said she was gonna pick me up. No, I did not.
18%.
Oh.
We got our total here, and we have our red here. All right. So I got 9 over 30, and then we don't know over 50 yet. So we'll figure that out. We can put an X there. Now, how do I solve these?
You got to cross multiply.
We cross multiply here.
And then divide.
So I got 30 times X and 9 times 50. Okay, 30 times X, that's simple as that. 30X equals, and what is 9 times 50?
15. Oh, no.
I just wanted 9 times 50. I want to show you what we're solving by.
450. Yes, 450.
450. And then what I do,
Divide by 30.
divide by 30 on both sides. I get X equals, ugly X.
X equals
So I get X equals 15 what?
50.
15 what?
No, red. 15 total.
15
15 red marbles.
red.
Go back to the question and see what we're asking.
Okay.
Right, same thing for the next one. You're on quality control again. Okay? An inspector randomly selects 200 pairs of jeans and finds 5 defective pairs. How many of the jeans could you expect to have a defect in them if you have 5,000 in a shipment?
So that's our total. Alright. So how would I set this up? We have a ratio box, and we also need to label it too.
We're comparing 2 things, right?
Jeans
Not just jeans, but what we just gonna go on bottom here. This is our
ship.
total. Okay, total goes there. What's gonna go at the top? What do we think is gonna go there? Huh?
100.
What are we looking for? It says about how many pairs of jeans do you expect to be what? Defective. So we're gonna look for the defective ones here. I'm gonna put it in red.
It's just like a fraction that we've been doing, right? The part over the whole. The defective is the part, the whole is the total. It's the same thing.
Alright, so let's take our information that we have. Okay, an inspector randomly selects 200 pairs of jeans and finds 5 defective. So that's going to be our what? That's our case studies, I guess, what we call that. For our experiment. So 200, and out of those 200, 5 are defective. So where am I going to put that at? What's going to go at the total?
200.
200. What's going to go as our defective?
5
5 there. Now, out of the total shipment that we have, okay, total shipment, where's that going to go?
Right next to it.
Bottom right. And we gotta figure out what, how many are defective here. So we get 200x. And what's 5,000 times 5? 25,000
Equals 125.
divided by 200. 125 what? Defective genes.
Just gonna go ahead and figure when y'all start tomorrow, we do break attentions for shadows. Unless we ask for you to shadow. Just your blanket warning for everybody, no matter who you are. Maylin randomly shouts out something. Yep. Or Peyton.
Don't
you know,
expect.
She's always shouting.
I don't expect them to shout out. You know the answer, you guys.
Oh, man.
It's okay, it restarts tomorrow. I'm not gonna start racking them up tomorrow.
Wait, it's not gonna count as strike.
Everybody got that? You good?
Alright, now, we're gonna hold off on this one because I wanna go over your homework with you. So look at your homework for a second. Remember, we're doing 10.2 as your homework.
That should be a good thing that we shout out.
We're excited that y'all want to answer and you have the answer, but it doesn't give everybody else the opportunity. We're a whole class. Alright, so looking at your homework, 10.2 is your homework tonight. Numbers 1 through 6 are like example 1 from today's notes. So if off to the side here you want to put example 1, it's like example 1. Numbers 7 through 9 is like the examples we just did, like example 4 in your notes from today. And then numbers 10 through 14 are like examples 2. So when you go back to look at your notes, that's where you can go look if you need help in your homework tonight.
No,
Guys, we still have 4 minutes. Harrison, you weren't even here yesterday. You won't get the chance to pack up early. Sit down. Love you. You ain't the only ones. You ain't the only ones.
sad.
I know.
No, I asked you.
Alright, shh. Y'all can have the first 6 problems done super fast already. You're not packing up till the bell rings. You got 5 minutes to change classes, and your class is literally right there.
You'll start off with like 8 and 9.
We start off on page 7.
what'd you think?